So we are going to see about alphanumeric displays in today's class. So we are going to continue with the special semiconductor devices, and in that, in last class we have seen about all the thyristor-based devices, SCR, UJT, diac, triac. We have seen just a completely different from those things. We are going to see about alphanumeric displays, how the displays are going to work. So these displays are we are seeing it daily in shops, in bank, in railway station counters. You have large display devices which are going to display various numbers, letters, and various signs in response to what you give. You give voltage or current, and that is going to be changed and displayed in the form of letters, numbers, characters, and signs. So these are going to be the display device which you are going to see, and they can be classified broadly into two types. It is called as active and passive. And as you know, active devices, they generate light just like LEDs. You give voltage, they generate light, and they display the thing which we design. So they generate light on their own. Those are active devices. And passive devices are called as light controllers. They don't generate light, but whatever light is going to fall on them, they are going to modify that, or they are going to modulate that. Example is LCD. So LCD will not generate light. So based on the light intensity falling on the LCD, they will modulate the intensity. Either it will allow the light to fully pass through them, or it will be completely opaque to light. So that is going to be passive display. So a beautiful example of passive display is LCD, and active display is going to generate light. So LED is going to be the best example for active displays. And these devices are completely optical. So on off, they are going to work in on off mode. On means you have light, off means you don't have light, it will not glow. Okay, so LEDs are mostly used because they have consume very less power, and nowadays LEDs and LCDs are more visibly seen in all the display devices where we have alphanumeric panels. And compared to LCD, nowadays even the more popularity is given to LEDs, and we have optical organic LEDs, OLED, we have quantum LED. So the technology is growing in such a way that we are trying to optimize the use of LED as a potential display device. LCDs were once used, but LCDs have a lot of drawbacks, so we don't use LCD as a display device nowadays in TVs and other laptops or computers anywhere. We use LED because the power consumption is less, the brightness the LED gives is very, very good, and it is not going to affect your eyes also. So we have to consider all these factors while choosing the display units. So two possible arrangements of optical displays are there. One is 7-segment display. So 7-segment display is what you see in the offices where they display numbers. For example, in bank counters, in railway stations, they display the train numbers, right? So each number is a 7-segment display. So you have 7 LEDs looking like an 8. So they will keep the 7 LEDs in the form of a 8. Okay, and depending on what LED you are going to activate, it is going to be turned on. So only that particular LED is going to glow. So you will get all the numbers from 0 to 9 in a single 7-segment display. And next one is dot matrix. So matrix, same way, instead of having a 7-segment display, you will be having a matrix type structure. So 4x4 matrix means you will have 16 LEDs, and depending on what current you give to what LED, you can choose which LED to be on for which particular symbol. So you can choose that. So possible ways of arrangement is you have two ways: 7-segment display and dot matrix display. So one way of producing an alphanumeric display is using a 7-segment display shown in the figure, which can display all numerals and 9 letters. So I'll just show you. This is 7-segment display. Okay, you see it looked like a symbol 8, right? So how many LEDs you have? 1, 2, 3, 4, 5, 6, 7. And all these LEDs are given appropriate current for glowing. So for example, you can see now in the 7-segment display, the letter 2 is displayed. For displaying the letter 2, what all LEDs you have to glow? You have to glow the LEDs A. See, the LED numbers are given. You have to glow the LEDs. See, 2 has to be looking like this, right? So you have to glow the LED A, you have to glow the LED B, you have to glow the LED G, you have to glow the LED E, you have to glow the LED D. So these are the different LEDs you have to glow if you want to produce the letter 2. Similarly for 0, 0 means all the outer LEDs you will be glowing. Because so it can display everything from 0 to 8. So it can display all the numbers from 0 to 9. Okay, so that is the beauty of 7-segment display. And since LED is going to be diode only, right? So it's a light emitting diode. So I can club all the anode of the diode together. Anode is the portion which is closer to your line. The LEDs, the diode symbol will have a triangle followed by line, right? So this line is going to be anode, and this triangle is going to be cathode. Correct. So if I'm going to use common anode, means I'm going to short all the anodes together. I'm going to connect all the anodes together. If it is going to be common cathode, means I'm going to connect all the cathodes together to the power supply plus V. And why I'm using the switches here means because all the LEDs will not be on at the same time, and I will be turning on the LEDs depending on my numeral 0 to 8, whatever 0 to 9, whatever numeral I'm going to display, I'm going to turn on only that LED. So two configurations are there: common anode and common cathode. Common anode is very simple. The anodes are connected together and shorted. Common cathode is the cathodes are connected together and shorted. Okay, so that is the two different types of the 7-segment displays we have: common anode and common cathode based displays. So each LED can be turned on or turned off to form the desired digit. So I need not keep all the LEDs on. So as we have seen in the number 2, for displaying 2, the LED C and F need not be on. So I will be keeping the connection for C and F open, while all the connections A, B, D, E and G will be closed, because current will flow only through a closed path, right? So these LEDs C and F, I will not disturb them because they don't play a role in displaying the digit 2. Okay, whatever be it common cathode or common anode, this LED C and F will not be turned on when you want to display the letter 2. Okay. So each segment has to be switched in order to respond to the digital signal. So you have to give the appropriate current to properly forward bias the LED so that it produces light. So we have seen for the letter 2 to be displayed, the LEDs A, B, D, E, and G have been switched on, and C and F have been switched off. So accordingly, you can give the connections. So C and F will be switched off, which means they will be open, while the LEDs A, B, D, E, and G will be kept closed. Current will flow through the LED. You are producing forward bias, so definitely they will produce light. These LEDs are going to produce light.